Okay, now let's proceed with human population dynamics. So as engineers or scientists, it is important for us to predict the population of humans. This is concerned in terms of food capacity. This is also in terms of the natural resources that we have. In this first paragraph, the prediction of dynamics of human population is concerned in determining the capacity for municipal and wastewater treatment system. Obviously, in a certain community, the wastewater treatment system and water reservoir depends on that community. Also, population prediction are also important in the development of resources and pollutant management plans. As we can see, should be also a study on prediction of population. So there must be a law that can be implemented to preserve the resources that we have, or at least limit the pollutants that we have. Now, in terms of dynamics in human population, it depends on the birth, death, and gender ratio. So if there are a lot of male, obviously there will be no movement on the population. And age structure, if most of the communities are senior citizen, then there is quite a static population. And dispersal, whether this community are mostly going abroad or not. So in human population, dispersal is referred to as an immigration and emigration. You are called as emigration if you go outside your country, and when you enter a foreign land, you are now called as immigrant, or you are now in the immigration. Now, in assuming the exponential growth of the human population, we have this formula that can be used for prediction. Right? So, P sub T is the population at time T equal to P sub O. P sub O is the initial population. Multiply with the exponential, R is the rate of growth times the time T, where the rate is simply equal to the birth, the death rate, the immigration, and emigration. Okay? So, let's go now with our first example. For our first example, I think this is already, for this one, let me just erase this one. Okay. For our first example, a population of humanoids on an island of Urot on the planet Zakak, so this is probably just a mind story, has a net birth rate of 1 individuals per individual per year. So the birth is 1. Then it has a net death rate of 0.9 individual per individual year. So D is 0.9. And then assume that the net immigration rate is equal to the net emigration rate. So I is simply equal to M. Okay? I is simply equal to M. How many years are required for the population to double? So that's the requirement letter A. Initially, you had P sub O. So when it will be 2 times the initial, or what will be the year or the time? Then letter B, in year 0, the initial population of the island is only 85. So what will be the population after 50 years? So these are the required. So let's try to solve this one. Solving first the letter A. Okay. So we need to solve for the value of our R. R is simply equal to B minus D plus I minus M. Our B is 1 minus 0.9. However, your I is simply equal to M, so this will be 0. So your R now will have a value of 0.1. The value of your R now is simply equal to 0.1. Okay? So, can we now solve for when will it double? So, we can now solve when will the population double. So, moving forward. So, the population when the population will double, we'll have a formula P sub T equal to P sub O e raised to RT. So, the population initial will double is simply equal to P sub O e raised to 0.1 and T is the unknown. P sub O will cancel out. Okay? So, what we have now is 2 equal to e raised to 0.1 T. So, let's bring this down. When we bring that quantity down, what we have now is 2 is simply equal to 0.1 t times ln e. And the value of ln e is simply equal to 1. Therefore, the population will double after how many years? 2 divided by 0.1? 20 years. So, the population will double after 20 years. Okay? Next, letter B. Let's solve letter B. Before we solve letter B, let me just move first this question. For example, number 2. So, let's solve for letter B. So, letter B, it says here, what will be the population, the prediction of the population after 50 years if the initial number of population in the island is 85? Okay, so that is e raised to the r is simply equal to 0.1 and then the time is 50. Okay, so 0.1. So this must be 0.1. Let me just write it again. So it will be much 0.1. So 0.1 times 50 will give you a value of 5. E raised to 5 is a value of 148.41 multiplied with 85. So there will be 12,615 individuals. So there will be 12,615 individual. Okay. So this is for example number 1. Let's proceed with example number 2. There is a growing city, had a population of 500,000 in 2005. So let's just give note on that. The initial population is 500,000 in 2005. No? In 2010, so after 5 years, the population was 760,000. Okay? So probably we can write this one as P 2005. Okay? So even if we don't write this one. Then next, in 2010, so this is 2010, what happens is the population becomes 760,000. Okay, predict the population in 2025. So obviously, we don't have the value of R. So you have to get the value of R first. Okay, so the solution, let's get first the value of R. Okay, so in 2010, the population is 760,000. The initial population is 500,000. So E raised to R, we are getting the value of R. And what is the time between 2005 and 2010? The time is after 5 years. Alright, so 760,000 divided by 500,000, 1.52. So here we have 1.52. Okay? Then, next, what we have is equal to, so you have R times 5, okay? Then we have ln of E. So this is simply equal to 1. Okay, so by the way, let me just correct myself here. If we perform ln here, we also must perform ln there. So we need to say, let's go back here. Let's go back here. Okay. At this point, 2e. So in order for us to bring down t, there must be a ln. So if we perform ln at the right side, there must also a ln at the other side. So this is ln 2 equal to 0.1 t ln e. So this is equal to 1. And that is ln 2 divided by 0.1. Ln 2 divided by 0.1. That is 6.93. 6.93. okay, equal to t. Or the time now is almost equal to 7 years. Okay. Next, let's proceed with this one. So for this one, 760,000 divided by 500,000, we have 1.52. Okay? So we have here 1.52 equal to e raised to r5. So we have to bring this down. Bring it down, we perform ln. So this is ln 1.52 equal to r5 ln of e. This is equal to 1. Therefore, the value of r is simply equal to ln 1.52 divided by 5. So that's 0.08374. So your r now is simply equal to 0.08374. So we can now solve for letter A. What is the prediction? Predict population in 2025. So 2005, so after when t is simply equal to 20 years. Okay? So what is the population at 2025? We have the initial is 500,000. E raised to 0.08374, 20 years. So what value is this? Okay, so we have 0.08374 times 20. Value is 1.6748. So e raised to that value will give you a value of 5.33, 5.3377 multiplied with 500,000. So the value is simply 2,668,000. So the population after 20 years will be 2,668,864 individual. Okay. Next, let's proceed with letter B. In what year will the population reach 1 million? Okay, so when will it reach 1 million? So let's have the 1 million here equal to the initial population of 500,000. Then we have E, our R is simply equal to 0.08374 multiplied with the time. Okay, so 1 million divided by 500,000 is simply equal to 2. E raised to 0.08374 times t. So in order to get the value of t, this must be ln t. This will be bring down 0.08374 times 10 ln of e. So this is simply equal to 1. Okay, so the value of time is simply equal to 8.3 years. So that is for human population. Thank you.